1, 2, 3. Hi everyone. Today we have special guests, Professor Francis Wyffels and Andreas Verleysen. It's very great to have you both here. Very exciting episode, to be honest. Can you briefly introduce yourself to the audience?
Yeah, so I'm Francis, and together with Andreas, we are here in the AI and Robotics lab, where we focus on general purpose robots, and especially on the manipulation part, so physical manipulation of challenging objects, such as glass, textile, folding t-shirts, basically doing your household chores.
I'm Andreas. I've spent 4 years of my life trying to have robots that fold our clothing at home so we don't have to do laundry. But today I'm looking more towards getting our robotics research in society.
From your perspective, what are the real capabilities of robotics today, and why do you think people shouldn't be afraid of them?
So in our social media feed and the news feed, we're seeing a lot of humanoid robots these days, which look very impressive. Like the videos we see and the associated capabilities from these humanoid platforms, they are really impressive. Now, if we look a little bit behind the scenes, we also sometimes make the remark that some of these videos are sped up to a factor like 10 times the original speed, while also some of these robots are actually behind the scenes a human teleoperating the robot. So it shows the nice hardware capabilities of these robots, but it still doesn't always tell us something about how well the tasks these robots are solving, how well they would solve them in other environments or with other types of objects. Take, for example, if a robot is folding a t-shirt, well, how well would it fold, for example, my hoodies or my trousers at home? So that's still a question we have today. And if we take a look at the robots in industry, like that are very active in manufacturing, these robots are still like just moving from point A to B, always the same positions, always the same trajectories. And this is at this moment the majority thing that robots are doing in our society. So although the promise is very nice, we still think that we're still at least a couple of years away from the general intelligent humanoid robot. And yeah, we're also wondering to which extent these models behind ChatGPT will really scale up to general intelligence. So that's why here at our lab, we are actively making robots more intelligent, but we're doing that in a couple of ways. So we look at also these modern AI machine learning methods, but we're also actively involved in designing and finding new types of robot arms, so different morphologies, but also like having a lot of research into something we humans inherently are using a lot, which is, for example, tactile sensing.
Yeah, so the key word here is generalization. So how can we scale up the generalization capabilities of our robots? And as Andrea said, we tackle this problem from a robotics point of view. So our goal is to work towards general purpose robots. And so, for instance, in the lab, as we will show during the tour, we focus on all kinds of tactile sensors. And you have to imagine you are pressing a switch or a button for a machine. You look at it, of course, but then you also hear, and the switch gives a noise when pressed in, and you also feel it. So that's the kind of behavior that we want to see for robots. Another aspect you are working on is reflexes. If something unexpected happens, for instance, someone is clumsy and that's a glass fall or something, then robots should be able to quickly adapt to that kind of situation like humans can do. And then none of that behavior is shown today, actually. So the AI, but also the hardware capabilities to sense environment for that are still far ahead. And that's exactly the whole the lab goal, so to say. Another way of thinking about the state of the art so Andreas talked about automation in industry. So there we could see it as a structured environment. So everything is deterministic. So this way of going from point A to B can be done easily. And we actually teach that also to our students in the first practical session, where they do a pick and place task within the hour with one of these robots we have in our lab. And on the other side of the spectrum, as a general purpose humanoid and the dream of everyone, also our dream, which is basically a robot that can handle tasks in unstructured environments. And we believe that today is basically the time to go to the semi-structured environments. And let's say, for example, a hospital or elderly care or a small company. Often they are semi-structured in a sense that you can access it with wheelchairs, draw limited objects, etc. So the robot can easier be taught how to do the tasks there. While in your home, it's total chaos. In every home, you have different chairs and objects, things to handle, too many tasks. So the generalization capabilities for that are far away.
Yeah. Even though actually I'm quite honored today to be interviewing both of you, because today we see robotics almost every day, which was not the case like few decades ago. And also we always hear about the robotics more often year by year. So in one of the interviews, you mentioned that over the past 100 of years, jobs have been constantly disappearing due to automation, while new ones have been created simultaneously. That's the key. Can you both elaborate more on this?
Yeah, so first of all, these are very exciting times now for researchers like us. And so every day a new technique, new robots are popping up. And from a lab and from a personal perspective, we truly believe in the concept of a robot helper. And what we are working towards on is robots that can assist with physical tasks that humans are doing together and for the humans. Let's say, for example, in a hospital or elderly home or care center, a patient is in a bed. Well, the ultimate goal of us would be to help a patient together with the nurse from the bed into a chair or wheelchair. And in that way, unloading the physical burden that people have to do. And of course, there is a job transition there. And so tasks becoming more and more automatable, but the technology needs to be developed, the sensors need to be developed, the mechanics, and that's still manual labor, as well a creative part, so the human intelligence necessary to come up with these things.
Yeah, so in these cases, robots are not like replacing human labor, especially not like in care industry, but will actually address one of the main problems that the personnel, like the healthcare personnel, is asking to solve, like help us physically with these tasks, both for logistics tasks, but also, for example, for the lifting people out of bed and such, to help them with that in order to avoid like future back pain problems.
I think this is another question that is mostly discussed all over the internet, and maybe it's more relevant that I'm asking it because I'm not from this research domain. So do you think AI can truly be creative, or is creativity something uniquely human, meaning that creative professions will remain a secure part of the workforce?
Yeah, so for us, it's quite hard to answer that kind of question because, first of all, you should be able to define what's creativity. We have been doing work together with artists and have some projects also with a non-profit organization, Django, where we focus more on the educational part. And with them, I had huge debates about creativity and whether then a robot can replace that a little bit. So I'm still quite unsure of it. And actually, I really don't know how to answer. I think to some extent, robots and AI become a tool for humans to fill in some creativity gaps and to use them in a creative way. But truly replace, I don't think so.
Yeah, and we won't know at this point, but we do know that all these generative models that are, for example, generating images and such, I think, like from a personal opinion, that it's too much for us every day to consume the amount of variations that these generative methods can create. So take, for example, in music generation, I still think musicians today are still very relevant. They can use these tools and they are actually a professional filter to get the good stuff out of it, because otherwise it's like just too much. So at this point, I don't think so. And also, if we ever get to the point of general intelligence, which is like for us, in our opinion, still far away, then we can have a real discussion. Because at that point, suppose we can build like a digital functional human brain, then it's the same function, just realized with electronics. So if we know how creativity works, if we can define it well, and we can do it digitally, electronically, then maybe
At the end of our lifetime.
Yeah.
Yeah. So the lab. We have some PhD students over here doing the research on the communication aspect of the robots, the central aspect, as well as the learning aspect. And on the other side we have the maker corner. We have 3D printers, we have milling machines. And so maybe we can explain first a little bit what Ewan is doing.
So today we are using AI to train robots to do different types of tasks. And one of the basic premises of using AI is having data available to show these robots what they need to do. And so one of the most natural ways to show a robot what it needs to do is by literally taking a remote like this, and use it to move the robot while you are controlling the robot, and take, for example, those blocks and put it in the right positions. So at that point, like, we are filming everything that is happening, we are recording in which state the robot is in, and we give that to models like similar to ChatGPT, which actually then where ChatGPT has to predict the next word in a sentence, this robot has to predict the next move it has to make in order to solve a task we want it to solve. Now, one of the things we are particularly doing here, which makes it interesting, is we are making our own sensors to put into the robot fingertip, for example, over here with all the wires coming out. And so we are basically using the tactile sensing we've put into the fingertip of the robot to also learn the robot what this feeling means, so that once it touches an object and then we do an associated movement with this object, it knows how to relate the sensing in its fingertips to the task we want it to solve.
Yeah, and with the VR headset, you can not only see through the robot, so what the robot sees over here with this camera and this one, but even works also on how to visualize, for example, how the robot grasps and feels, so you get some kind of tactile feedback, but also tactile visualization, and we can do that with all kinds of sensors.
But it's still like it can be difficult to control the robot like this. You need some time to learn how to control a robot with a remote. This is currently like a big thing in industry right now, that we have a lot of these robots all stacked next to each other, with people standing behind the robots with the VR headsets on and moving them all day long in order to generate the data to train these big models, AI models that can solve certain robotic manipulation tasks.
Yeah, and then of course to integrate all the sensors, the cameras on the robot, we have a maker corner with 3D printers, milling machine, soldering station. So most of the hardware developments we can do in-house. Electrical engineers here can solder, but of course these are basic setups. If we have to do more advanced, we can go to the clean room, which is actually also part of the campus over here. So that's also, it looks like a real lab with a lot of, sometimes we have to clean up, but these are like ongoing things. Yeah, so here we see our mobile robot setup. So the mobile robot setup consists of an articulated robot arm which can serve drinks. And we have a lot of glasses over here, going from very small glasses to, let's say, big beer cups. And we can basically pour in any glass that you put in front of the robot. So Louis is doing his PhD work here on giving drinks and bartending and how to teach robots to do that. So he can explain a little bit more on what he is working on.
Okay.
Yeah, so the robot will pick.
Yeah, so right now the robot is looking for glasses. When I put an empty glass in front of the robot, you see it will react, and it will then take a bottle and pour it into the glass. So this is all live planned. It knows where the bottle is, it knows where the glass is, and it plans dynamically a path to pour out the juice. Voila. At this point, when it sees the glass, it can also see that the glass is already full, so it won't try to re-pour into the same glass. Cheers!
Yeah, so this is the second lab, and the goal is actually we are building a new building, the AI Campus Hub, or the brains. So there, both labs should be becoming one big lab with a fake kitchen, a fake living room, etc. But for now, it's spread over 2 labs. So here we see some of the sensor technologies we are working on. So this is, so on Uwen's robot, you saw a thick finger with tactile sensors. Well, this is like the interfacing ring, and this is some other type of tactile sensor, but more optical, so that we can fold t-shirts, follow the edge of a t-shirt. And this is all built in-house. And then we can even make electronics very thin. So this is together with the befriended lab of 2 floors down, we make this kind of stretchable textile materials. This is handy for one reason, because if you are folding t-shirts with robots, then you can actually observe the state of the t-shirt. So the t-shirt, so to say, can feel it's folded or not. But also, this is a really thin technology, so we can easily make a skin for a robot arm. So we can put like this around it, and so it can like feel proximity and tactility. or we can also easily integrate this technology into in very thin fingertips. And yeah.
Now let me first show you like why is these types of things, like this interfacing part, why is it so important? Because for robots we often end up like this, like I call it like robot spaghetti. They're all like wires around these robots because we want to give additional hardware to these robots, equip it with new different types of sensors, but we end up with things like this which really get into the way this robot is moving and it gets entangled in its cables. So that's why like we're generally looking at these types of things to have these cables just from the fingertips to here, and from this part actually connects with the robot wiring inside instead of just around the robot.
Yeah, and on this setup, Raman over here is testing imitation learning together with camera and a microphone sensor, which is in the fingertip over here, to learn how to manipulate switches and buttons, and buttons of your clothes, but also of machines. So this is an artificial button, and if you press it, then you can hear the sound. And that's what we are observing then with the robot.
Because this is also something that's almost impossible to see with, for example, a camera, that whether you have pushed a button or not. In general, also as a human, we get some tactile feedback because we're pushing the button, but you can also hear the click of the button. And as a human, we use these signals. And we try to replicate these ideas about how we are using these cues from the environment if we interact with it, and also put it into a large AI model for robots to use to control their hardware.
Yeah, and in that way we can avoid that, for instance, the robot presses a button too hard because it's vision only, because then at a certain point all the machinery in your home will be broken because you have like a robot pushing the buttons very hard, or pushes like too little and the machine is not accurately switched on. So that's why we also focus on the sensors. Yeah, and these are like setups with one arm, but of course sometimes, like in a humanoid shape, we want to combine two arms. So here, for example, we have a setup with two arms, which we can also teleoperate with this joystick over there. And this is actually the setup where we won the cloth folding competition 3 years ago. So cloth folding is a thing in robotics. Now you see it slowly being commercialized, but 3 years ago we won both the AIRO and the AIRO robot competition on t-shirt and towel folding. And last year we also organized it. So, and there, of course, the difficulty is that the two arms have to collaborate with each other. They have to synchronize, and otherwise the t-shirt can be torn apart. And in the background of the robot, you see some glitter. That's actually on purpose. And so, although we are in a lab and we want to learn and try the tasks with clutter in mind, because also, of course, in your house there's also clutter, and the robot needs to be able to deal with that. These are causing artifacts in the vision pipelines of these robots, and that's why it's so dirty in the back, I would say, and many different objects. And we switch that once in a while, and we change the lights here just to be able to generalize towards all kinds of environments. Yeah, so this might seem like a curiosity. It's actually a digital camera without a screen. So we put it in the lab so that students and colleagues can just take random pictures of what is happening, like this. I'll also take actually like what's happening here. And you cannot see the picture. So basically, at the end of each semester, we reveal the pictures on some kind of team building activity we do. And it's just nice for us that students like master students or bachelor students who are sitting here, they take often pictures with their cell phones, but we don't see them. And by giving them access to like a lab camera, then at least we see some of the progress and some of the funny pictures.
So, for example, in our course, where we're teaching students how to make intelligent robots, at the end of this course, they have to fill all these holes with different colors and make some art or write a message. And we actually have like a very nice picture, like they are very proud of their work because it's a nice achievement if you can do this at the end of the course. And what they then do is they put a paper on top, turn it around, and then they have their art made by a robot, and they're all taking like a picture of themselves being very proud of their achievement. And we also want to capture these moments with that camera.
Yeah, and starting from the 1st of January 2026, our website will be updated, and like every day there will be a new picture from that camera be put automatically on the website. That's like a kind of, again, triggering curiosity, right? So we want that people see like curiosities in our lab and then are triggered to come and collaborate with us.
What is life like in a robotics lab?
Yeah.
So, how do you see robotics shaping the future of everyday life in the next decade?
So I think in the near future, if we look at the structured to unstructured environments, and so today we have robots in warehouses and manufacturing, so structured environments. We also have some service robots, let's say, in semi and unstructured environments. Suppose maybe you have a grass mowing robot or a vacuum cleaning robot. So this is what I mean with service robots. And the number of services will definitely increase in the coming 2 to 5 years. And then what we think that will happen is that robots will become more and more general and combining some of these tasks. And the set of tasks that the robot will be able to do will increase up to a point where we will reach ultimately maybe after 10 or maybe even 20 years in a humanoid shape doing more generic tasks.
Preparing for this interview, I looked up some of the works you've been doing. It's very interesting what you're doing, and also that you are intensifying like more initiatives like Duolingo and some other DIY projects. I think that's very nice that you are sharing the knowledge that you have. So how do robotics help inspire young people to pursue STEM fields?
Well, I think some takeaways there is like we are passionate about robots and AI, and we see a lot of young talent out there. And I think if we want to position ourselves worldwide on a competitive level, yeah, at least we should attract people into science and technology and mathematics, education, and ultimately maybe become a researcher in our lab, of course. And that's also the reason why I started this non-profit organization, Duolingo, more than, I think, 16 years ago, 2009. Because then we can, let's say, offer teaching materials to teachers so that they can teach in their classrooms about topics such as AI and robotics, but in a way that is suited in the official curriculum. Because I really think it's important that everything has a root in the official curriculum and the knowledge they have to have about sciences and mathematics, so that it's really used in the classrooms. And currently we have projects which have been done by more than 50,000 children already. So yeah, by doing this kind of work, we hope that we can trigger some interests, and ultimately maybe they can co-develop robots with us.
Yeah, we see that inspiring people using culture is like very important. We now see it also, to pin back to the beginning, we see it in the humanoids hype at this moment. Why are companies building humanoids? One of the excuses, like, we are building our world around us for the humanoid form, us. But one of the other reasons is, everybody dreams of this science fiction idea of the robot that's like a human. And that's just one of these reasons is because of science fiction, and we were influenced with it on an early age already. And I think that's why these STEM programs are so nice. It help those coming to contact with these dreams and actually make it accessible. It was very difficult before these programs were out there. As a young person growing up, you dream of these robots, but you couldn't realize it anywhere. And robots are complex technologies, but they become very inaccessible without these STEM programs.
I completely agree. I didn't realize how much I like building robotics or mechatronics engineer, because I recently bought NASA's rover, Mars rover, which is quite cool. I'm very excited to actually try my DIY. But I'm also interested to know what inspired you to this research field. What sparked your interest?
Yeah, it's like, hard to say actually. So when I was in elementary school, actually I wanted to become a vet. I was all into animals. But then it switched when I was 12. I wanted to build a robot. I got into computers and programming. And actually it took quite a while until I was able to build a robot. So my first robot dated from when I was 16. I wanted to build like a light eating robot. But actually it failed entirely because in the schools back then, there was not much about technology and engineering, and also my parents, they are not into this kind of stuff. So I had to wait until my master's, where I did a thesis in robotics, and that's how I somehow got into it. But I would dare to say, I switched my interest from, let's say, living animals to the animats, to the robots. That's how I see it. And I find it always intriguing how we can make from just electrical, mechanical components and software something that slowly gets alive. You see it also here with all the robots. All the robots have a name. It's very human to do. It's kind of strange actually, or maybe even a little bit silly, but nevertheless, there's no robot here that doesn't have a name. And to a certain extent, even our computers have a name. So we make it, we give it somehow a personality, and even name the flows. And so I think, that's what triggers me at least.
My story is a bit simpler. I was always the computer nerd that likes to program software, and I think many people who have developed software can relate that you press the play button and the software pops up and it starts doing the things you wanted it to do. It's like, especially the first time you do it, it's a very special moment. But with robots, it's even more extensive, like, because you have a real physical platform, and you build everything, like, you build everything up, you hook your software to it, and you press play, and instead of just looking at your screen, you see the physical movements. And it's really, even up till today, it's a magical moment. So that's at least what got me into robotics.
Yeah, it speaks to the imagination of many people, I think.
Actually, apart from Duengo, you are also involved actively in educational projects. And as I said before, it's very exciting. I'm very inspired by you that you are sharing your knowledge with younger generation and trying to grow more people into this area, which is the future. So you also have other projects like TICS, We Go STEM. So with the following aim in mind, young people can learn basic computer science concepts from an early age. So can you share what did inspire you to work on this direction, but I think you already mentioned a little bit. And what interesting insight have been gained so far?
Yeah, so basically, if you look at my story on how I got into robots, it's also a little bit out of frustration. So I was only able to build a robot myself when I was, let's say, in my master's. So it took me a while, and when I did my PhD, together with some colleagues, we thought basically what can we do about it, and that's the roots of the non-profit organization Django, with all the projects that you mentioned. So we go STEM kicks, also the work on computational thinking, the robot competitions, they are all part of the Django organization. And there we make like open source materials, so they are freely available, except the hardware, they have a cost. But therefore we try to find sponsors so that we can distribute them freely. So for example, we go STEM is actually a kit that teachers can borrow from the public library in every province. So it's really cool, that kind of outreach we have. So yeah, I would say it's a little bit a negative story. So it came out of frustration, but we turned it into something positive, I think. So
what are general reactions you get after these projects or during the projects?
Well, it's so in the beginning we focused more on hobbyists, and their reactions are on a very broad spectrum. As some people find it really hard, the materials we have, but we switch more towards teachers and try to really help them to integrate it in the curriculum. And yeah, there we see a lot of very positive reactions, because it's really tightly coupled to the curriculum. What's also interesting there is that we have done projects also abroad, and there you see also interesting cultural differences on how to learn new concepts, and how to internalize new knowledge and new concepts, and doing hands-on work. Some regions where we have been, children are more like reluctant and careful before they do something, while in other situations there is all enthusiasm ahead. But ultimately, like all these different regions where I have been, we always reached our goals, and always we had a nice exposition of like robots doing stuff. So yeah, that so there are some differences, of course, but in the end, with education, everyone gets on track.
Yeah, I think here as well, the representation matters as well, because during my age, we've grew up with very scary robotic movies, like a lot of them. I guess Hollywood did a great job on that, scaring us all, my whole generation apart. But now that I see the new being released movies, they try to show the robotics more in a friendly manner. Do you think this also has an impact on people's perceptions of robotics as evil, or as more friendly, or as very smart tool?
Yeah, the Terminator movies didn't help in the perception of technology being evil. So yeah, our vision is more robotics for the good, and we really use the word robot helper. And yeah, I think movies like BMAX and is actually a good example on putting a more friendly robots in a movie, and also to see a little bit in a movie where how people work on this. And we have the lab tour. You see young people who are very intelligent working all together on this common goal from different disciplines. So I like that this is also depicted now in more modern movies, when, let's say, in the past, in the 90s and even around 2000s, was always in a negative image. As also the purpose of Django. I mean, by knowledge sharing, we hope this fear of technology is decreased, and that we can trigger enthusiasm. and that basically passive users become also maybe technology pushers or even creators. That's the main goal.
Yeah, the thing is that these types of movies are also considering like the general intelligent robot. Well, so probably decades away from that. But like, you won't see a movie about just, a static robot arm like here, where we put a basket full of laundry in front of it and it starts picking it apart and folding it like that. I don't think it would make an interesting movie, but while we were doing this type of research, if we talked to people, everybody was like, oh yeah, I want this at home. So how much money do you need? And it's actually the same with now, like helping people in like care industry with physical tasks. So, but we won't see movies about that yet. So, although this is where we are currently evolving at with robot technology at the moment.
Yeah, if I'm not mistaken, I think it was the very huge impact had of the robotics perception, making it very cool thing is Iron Man, I guess, that I could remember of. But in this manner, I just want to ask you, like, because perhaps for other people who are listening to this episode, it would be interesting to know what is your favorite movie and why?
Oh, it's not a robotics movie, that's for sure.
But, oh, yeah. But if it has to be in the domain of robotics, I'm more a book guy. So if that goes, I'm a big fan of the Culture series by Ian Banks. Unfortunately, he died a couple of years ago, but he actually has it's a science fiction series, and he has a vision on how general intelligence embedded into robots should look like if we want to do this right, and how it transforms and uplifts society as a whole while still having actually like negative consequences. It's like a vision we should try to achieve, but we should be aware like if we have robots that are much more capable than us, but which would free us from like difficult labor, it would be very nice and it would be a net benefit for humanity, but it will still have consequences. And that's something I really like, the way he is very nuanced and specific about that. So for me, the Culture series books.
Yeah, if we have to pick a movie, it's not my favorite one, but I think it's intriguing from a robotics perspective. It's Ex Machina. Because actually there, one of the things I like is how they thought about out of the box of the computation. So they went away from, let's say, the standard chip, and one of the breakthroughs in the movie to get this AGI or embodied artificial general intelligence was to have some kind of biochip, so which could be seen as unconventional computing, and yeah, that's also triggers me. First of all, in the lab, we are doing also research on unconventional computing methods. So in standard, rather than using standard neural networks or GPUs to compute those, we use other means. But what is also intriguing there is this new chip was the breakthrough in that movie. And today we are at the point that we have huge large language models, such as ChatGPT, Claude, Gemini, etc. They also become embodied. So slowly we are moving towards LBMs, or large behavioral models, with which we can control robots. But we are seeing limits on data collection, but also on energy consumption. If you want to infer a huge model, so if you want to use that, you need a heavy GPU. It consumes a lot of energy, and so I think we also probably will need that. So there's also work need to be done on the computing technology. And the movie depicts that aspect also very well, I think. Apart from the gruesome killing machine that the robot becomes, and the other aspects.
Generational trauma.
Yes.
Yeah. looking ahead, what's your biggest hope for how the projects you are working on today will impact the world?
I think I speak for both of us that we want to see our work from our lab in society, and and one of the projects we are currently working on, there we are doing work on robot helpers for healthcare situations, and yeah, it's definitely our dream to see that happen, and we really want to put that in a helpful way. So that's why we keep close contacts with the healthcare sector, so that this robot becomes extremely useful for the people over there. So that it's not some robot that in the end becomes like an object in a closet, or curiosity, or that people don't want to adopt the robot or use it. We really want to set some really useful robot helper into the market. So that's my, let's say, biggest lab dream at this point.
Yeah, so these robots, we say like they are coming and we need to do it right. We need to introduce this technology in the right way. Not like, for example, the creator of the Facebook like button, for example, he regrets this technology, that he invented the like button, because also a little bit like generational trauma. With all the dopamine requirements you get from this like button. So it's very similar. Let's do robots. Let's do it the right way.
I'm sure that there are a lot of young generation who are listening to this episode who are inspired. Maybe they're watching Ex Machina or maybe reading the books you suggested. So for them, what skills do you believe are essential to teach first in schools and second to develop for incoming PhDs?
Well, I think in Belgium, the basics are fine. So pay attention in mathematics and science courses, of course, that always helps. But actually here on our floor, it's not that we recruit people only from, for example, computer science or informatics education. So we have an interdisciplinary group, and maybe it will surprise, but we even have a biologist who does a PhD in collaboration with the Department of Biology, of course, to make new kinds of robot arms and grippers, and that's really important. Nevertheless, the STEM direction you are going from, you will be able to contribute to robotics, because we really need that out-of-the-box thinking. And to a broader extent, and these robot helpers, they will navigate and do tasks with humans and for humans. So we should not neglect that part either. So there are definitely social aspects to it, psychological aspects to it. So these are also really important. So and I truly believe that roboticists like us should be in close collaborations with them too, because we want to humanize our robot helpers so that they are fully useful in a proper way.
Yeah, because robotics brings so many disciplines together. If you're from any discipline you are, probably can contribute something to robotics, which is what makes it a nice field. So as a general tip also, like stay curious, learn from a lot of different disciplines, new knowledge, because it probably contributes to robotics.
And ask questions all day long. It's basically our job. I find flows and existing things, ask questions about it. Maybe also criticize sometimes, but also our own work. So be critical. That's really important. Stay curious about the world.
I completely agree. That's the whole purpose of this podcast, actually, to promote curiosity and make the knowledge accessible. So do you have any advice for incoming PhDs in robotics and AI?
So my first advice would be do research in niche domains. Currently, there are so many people working on AI and also in robotics. If you if you plan to just collect a lot of data and try to solve general purpose tasks like cleaning a table, your work will probably vanish among all the other research that's being done for that. So I think finding a niche, some domain that not many people within robotics are working on, is very important. Hence, that's what took us into both the textile folding, the deformable objects folding for robots, but also into the electronic sides, the sensing sides, because in robotics, it has been neglected for so long that touch fingertips is so important, while a large part of the community was trying to solve robotic manipulation with cameras only. So find a niche.
Yeah, indeed, and that's what we try in our lab. One of the complementary advices to that to a young PhD student is don't be overwhelmed by all the work on deep neural networks for robotics. And there's a lot of out there. It's barely followable, but try to follow your own path, your own niche, and do it thorough. And dare to evaluate thoroughly, go into the deepness. For instance, we with the glasses, and we poured in more than 500 glasses. Then we went to several environments. We did many exhibitions just to make sure, and just to be sure that we could say with 0.7% failure, we can pour in any glass that you put in front of the robots. And we are confident about that now because we tested in a very thorough way. So I really like this slow research part as well, which is a little bit interdisciplinary, and yeah, in that sense, don't be overwhelmed by what you see on YouTube or what the so-called bigger labs are doing. It's really important to follow your own vision.
Yes, completely agree. First, thank you very much for being a guest today in this episode. It was very nice to have both of you. I also would like to thank you actually for making the knowledge accessible for everyone. This is something very meaningful that you are sharing your knowledge with younger generation, making it accessible, trying to reach out. I think this is a huge effort as well. You said that it was not an easy job, and also not. Of course, as academics, we would like to publish our works, but you are directly implementing it into the society. I think that's something very big. Thank you very much.
Cool. Yeah. Thank you. Thanks.